This is a three-part series on the topic of how blockchain can transform the supply chain. Today we're speaking with Julio Franca, who will discuss this topic. So Julio, my first question is, how does blockchain, or how can blockchain transform the supply chain?
Supply chain has become complicated. Some would say cumbersome. It takes days to make payment between a manufacturer and a supplier, or a customer and a vendor. Yeah? So contracts must be handled by lawyers and bankers, which means extra costs and delays. Product and part are often hard to trace back to suppliers, making defects difficult to eliminate. Whether for industrial equipment or consumer goods, food products or digital offerings, supply chains have headaches aplenty. Friction in supply chain is a big problem. There are too many go-betweens. There is too much to-ing and fro-ing. The rise in uncertainty stops supply chains from working well. Suppliers, providers, and customers must deal via central third-party entities instead of directly with each other. What should be simple transactions turn into lengthy procedures with many steps. Blockchain could be the answer to many of these issues, right? The recent technology is what drives Bitcoin and other so-called cryptocurrencies. However, it goes much further than a hack-proof way of holding and exchanging money. Blockchain can be used for any kind of exchange, agreements, or tracking. For example, in a supply chain, it can be applied to anything from self-executing supply contracts to automated cold chain management.
Thanks. My next question is, can you give us a blockchain primer for supply chain?
Well, what's blockchain? Here's a simple explanation. A blockchain is a distributed digital ledger. The ledger records transactions in a series of blocks. It exists in multiple copies spread over multiple computers, which are also called nodes. The ledger is secure because each new block of transactions is linked back to the previous blocks in a way that makes tampering practically impossible. And it's decentralized. It does not depend on any single entity, for example, like a bank, for safekeeping. The nodes connected to the blockchain network get updated versions of the ledger as new transactions are made. The multiple copies of the ledger are the truth about every transaction made so far in the blockchain. Trying to falsify the ledger would mean having to falsify the copies at precisely the same moment. The chances of being able to do this in blockchain networks of any useful size are negligible. That's all a bit abstract though. Let's take a closer look at the real-life example of Bitcoin. It's important to recognize Bitcoin has just one way of using blockchain. However, it also happens to be one of the best known examples. Bitcoin is a recently invented currency that is separate from any state-controlled currency. Entirely digital, it exists thanks to the distributed ledger of transactions on computers across the world. You can buy Bitcoin from Bitcoin exchanges. You can then use Bitcoin over the internet to make and receive payments. Each payment transaction is added to the ledger, which can be consulted by anyone at any time. Details like the amount, time, and date of payment are visible, although your personal identity is not. Bitcoin holders, therefore, usually do not know each other. To deal with this anonymity, Bitcoin uses another distributed mechanism called mining to add blocks and transactions to the ledger in a secured, tamper-proof way. Well, let's talk about a bit applications of blockchain supply chain. The following examples are now in use and can be, for example, implemented in today's using technology. Example 1, set automotive supplier payments. Blockchain allows the transfer of funds anywhere in the world. So traditional banking methods are not needed. Transfer is directly between payer and payee. It's also secure and rapid, in minutes compared to days for automated clearinghouse payments, for example. Bitcoin transfers specifically also offer lower fees. Australian vehicle manufacturer Toncar uses Bitcoin to pay suppliers. Currently, 3 partners in Israel and Taiwan accept this. Toncar suppliers' agreements use standard terms. The advantage is in the cost savings. On the other hand, the firm is careful to avoid hanging on to too much Bitcoin. While Bitcoin is international by nature, some national governments see it as a way for companies to make an investment, and then therefore companies with Bitcoin holdings may be taxed accordingly. Example 2, meat traceability. Product status at each stage of production can be recorded using blockchain. The records are permanent and inalterable. They also allow the tracing of each product to its source. Global retailer Walmart uses blockchain to track sales of pork meat in China. Its systems let the company see where each piece of meat comes from, its processing and storage, and sell by date. In the event of a product recall, the company can also see which batches are concerned and who bought them. Example 3, electric power microgrids. This example shows how entities of any size can use blockchain. In other words, blockchain is not just being for the big players. Smart contracts are being used for redistributing excess power from solar panels. The transactive grid is an application running on blockchain to monitor and redistribute energy, and a neighborhood microgrid. The program automates the buying and selling of green energy to save costs and pollution. The technology for running the program is the Ethereum platform, designed for building smart contracts of any kind. Example 4 is the RFID-driven contract bids and execution. The RFID tags are commonly used in supply chain to store information about products. The tags can be read easily and automatically, then processed by IT systems. So the logic goes, why not to use them for smart contracts for logistics? The practical setup could be as follows. RFID tags for cartons and pallets store information on delivery locations and date. Logistics partners run applications to look for these tags and bid for delivery contract. The partner offering optimum price and service gets the business. A smart contract then tracks the status and final delivery performance. And the final example 5, cold chain monitoring. Food and pharmaceutical products often need special storage. Also, enterprises also see the value of ensuring warehouses and distribution centers instead of each one paying for its own. Sensors on sensitive products can record temperature, humidity, vibration, and other items of interest. These readings can then be stored on the blockchain. They are permanent and tamper-proof. If a storage condition deviates from what has been agreed, each member of the blockchain will see it. A smart contract can trigger an action to correct the situation. And depending on the size of the deviation, this action might be to simply adjust the storage. However, it could also extend to changing use by dates or declaring products unfit or applying even penalties.